Hello, machine learning fans. Welcome to our deep dive into boosting. Most videos on ensemble learning show you the math but skip the sequential logic that makes it powerful. In this video, we want to show something different, how models learn like a student in a private tutoring session, focusing specifically on their past mistakes. Imagine a student taking a practice exam where, instead of just grading the whole paper, a tutor identifies exactly which questions were missed and builds the next lesson around those specific gaps. Building on our previous talk about bagging and how parallel models can reduce noise, let us look at the fundamental shift in boosting. While bagging builds many models at the same time, boosting builds them one by one in a strict sequence. Each new model is not just a copy, it is a specialist designed to fix the errors of its predecessor. It is the difference between a classroom of students all reading the same book versus a single student getting a series of personalized lessons. In the first round, we train a simple model on the entire dataset. Think of this as the student's first attempt at a practice test. The model does its best, but it inevitably gets some things wrong, which we highlight on the answer sheet. In our tutoring analogy, these missed questions are the most valuable pieces of information. Now comes the clever part. We increase the weight of those incorrect answers. In our tutoring session, the tutor circles the wrong answers and focuses the next hour exclusively on them. By making these errors larger in the eyes of the next model, we force the algorithm to pay more attention to them. This ensures that the next round of training is not a repeat of the first, but a targeted intervention. The second model is trained, but it is heavily biased toward fixing the mistakes of the first. It is like a specialist tutor who only teaches the hard chapters. This second model might get some easy questions wrong, but the first model already knows those. Each round, we look at the remaining errors and bring in a new specialist to tackle them. After several rounds, we have a team of specialists. To make a final decision, we combine their voices, but we do not treat them all equally. This is like the student taking the final exam using combined wisdom from every tutoring session. The result is a highly accurate ensemble that is much stronger than any single model alone. Boosting is a powerful strategy because it turns a collection of weak learners into a single strong predictor. Remember the tutoring session, start simple, identify errors, and focus the next effort on those gaps. If you found this sequential approach fascinating, hit the like button and subscribe for more deep dives. What concept should we tackle next? Let us know in the comments below. Subscribe to master more complex concepts through simple analogies.